So that I can formally introduce Fred Zelt, all right, so I got to give you a little backstory here. Fred, when was it that you gave this presentation to DCNR? Was that like last spring or summer? I don't know.
I did a webinar in April.
That's what it was. Okay. So
yeah.
he gave this webinar in April, and I'm watching. It was amazing. It was really cool. And I was like, hey, I need to ask Fred if he would do a Hags talk. Before I even got around to it, 3 other people emailed me and said, hey, you should get Fred to do this talk. Like, so there's a lot of excitement that he's able to present this to Hags. And on another note, how I think it's kind of exciting that we're moving into geology. I don't know, can I call it non-traditional geology? Like how geology impacts other disciplines. Last month, we heard about ecotourism and how the geology of the caves in Belize. And so here we're going to have an architecture lesson of sorts and with a geology slant. So I'm excited about this, looking at geology through different lenses. But you guys didn't come here to listen to me ramble on, so I'm going to turn it over to Fred. And Fred, you have the microphone, so go ahead and get started.
Okay, thanks, Alan. I'm sorry I couldn't be there in person. I really was looking forward to meeting more of the folks there. I know I have some friends on the survey staff and otherwise in the area. I'm really sorry I couldn't come. I've never even seen the facility. And for me, as an undergraduate, it was kind of a dream someday to work for the survey. I did get to work for the USGS for a couple of years, but then I spent 30 years with Exxon and ExxonMobil, and now I'm retired and living in Pittsburgh. And the GSA annual meeting came to Pittsburgh a year ago. I offered to help lead a trip with a couple of colleagues, including Jim, to Ohio Pile and to the Erie Lakeshore, where I'd led lots of public geology-themed trips. And I thought, if they don't get tickets to Fallingwater, none of the 5,000 geologists coming to Pittsburgh are going to go, because you can't get tickets at the last minute, especially this time of year. So I offered a coach bus trip, not realizing nobody had ever really studied the geology of it before, and there was no field trip guide to go by. So I ended up spending 400 hours on this last year, and luckily Jim came to the field with me, and I could build on Jim's good work from the past. And luckily Grant flew on his own dime down from Canada to help me identify scientific names for trace fossils and to test my ideas about depositional environments. So I'm really grateful for the opportunity to have done this. There have been 7 million visitors here since this house opened to the public when the Kaufmans gave it to the Western Pennsylvania Conservancy in the early 1960s. It's one of 8 Frank Lloyd Wright sites that are part of a UNESCO World Heritage Site. To be a World Heritage Site, a site has to have global significance. It has to be important to people, not just in the region or country, but around the world. And I think you can see why from this view. This is the pinnacle of Frank Lloyd Wright's phase of organic architecture. It's a stone house sitting on bedrock, built around boulders, and it fits in the setting. You can see how it echoes the setting and is in harmony with nature that way. So there's a lot of geology in this, and I feel really lucky to have been the first person to have been able to take the time to take a close look at this. But still, this is a reconnaissance scale work that was done in 2023, and I invite others to come work on this. So the webinar that's recorded, it's on YouTube, the Fallingwater webinar from April, that was meant for the public, and I don't use a lot of geology terms there. I'm going to assume that people watching this, listening, are geologists, and that you know basic geologic concepts. So I'm not going to explain those. And that'll give me some time to add some geology slides and maybe talk about things that I think other people could do in the future if anyone chose to study this. So let's move on. These are common scenes. If you've been to Fallingwater, you'll probably remember some of these scenes. And as I said in April, if you haven't heard this talk before, I think you'll see things in a new way in these familiar places. These are some of the people who helped me. The field conference that was in Ohio Pile in 2022 really taught me a lot, and I was able to build on the knowledge that people had generated that was expressed during the conference, really generations of knowledge. But you can see some of the key people listed at the top. Folks from the Conservancy were really welcoming of free geology being done here. And I'm sure they would be in the future of people who are respectful for the landscape and the protocols they have in place to preserve this important site. And I mentioned UNESCO World Heritage. I forgot to mention, there are only 2 other sites in Pennsylvania that are UNESCO World Heritage sites, one being Independence Hall, and the other, just this past year, the Moravian complex in Bethlehem. So this is the only one that really has a lot of geology. There are stone houses in the Bethlehem one, though, too. Again, conservancy people helped. Folks in the survey, I could ask questions. They would help a lot that way. And being able to put this through the editing process and getting a peer review and professional editing help with a geology field guide was great. So now there is a GSA field guide for the annual meeting last year that exists. It's the first publication that focuses on the geology of Fallingwater, and a lot of these illustrations are in that. You can see my co-authors there, Jim Shaulis at Paradise Overlook and Youghiogheny Gorge. You can see Grant Walk, who is on the staff at Dalhousie. So folks at Lynn Hall, which hopefully I'll talk about a bit later, they helped a lot too. I'll show a couple slides from Tybee Island. I had a contact at Taliesin, a studio and home made of stone that Wright built in Wisconsin. That was helpful. Got some help from the Columbia University, and you can see folks who shared key illustrations. And for all of us, all 3 of us, this was just on our own dime. There's no taxpayer money that paid for this or grants or anything like that. But this being, such an important site, I would imagine future researchers, if they come up with interesting projects that'll benefit the public, I'll bet you wouldn't have a hard time getting funding for this. Okay, you can see the location of it. It's in the high part of the plateau, in that section of terrain. I really don't think I need to explain the geology to you. You'll know it better than I do, Pennsylvania geology. You can see the folds in that terrain. Here are the tight folds of the Appalachians. You go across the Allegheny front. There's the broad fold of Chestnut Ridge, Laurel Hill. It sits in the Ligonier syncline in between those two, right next to Youghiogheny Gorge, and a tributary of Youghiogheny River and in the Youghiogheny Gorge area. And then, of course, there's the low plateau off to the west. I'll show you a cross section in blue. The yellow is the field trip location. We rode a bus from Pittsburgh to Fallingwater and back. So there's a cross section. This one's from Ryder, so it's a pretty big scale cross section. You can see the Allegheny front. You see the detachment rise up here. And you see there's a detachment in the Silurian, shale and salt there, that helps core these anticlines in the high part of the plateau. And where we are is near the axis of the Ligonier syncline. And you'll see a contour map of that syncline on one of Jim's maps later on. So that's where we are structurally. The field trip guide that's published in the road, in the guidebook for Ohio Pile, has a road log. So it talks about the route along the turnpike and everything. And I'll just mention that survey publications, including one from the 1940s, were helpful with putting together that road guide. You can't just stop on the turnpike and measure dips. So I was able to use a 1940s survey publication to be correct about bed dips along the turnpike there. So lots of good stuff from the past. This is another page. I think this one's from the Ohio Pile field guide, but you can see the location of Fallingwater is up here. This is Jim's geologic map within the Laurel Highlands there. You can see there's a fault near the crest of the Laurel Hill anticline. There's the axis of the Ligonier syncline. The star is the OSP1 borehole. That was key too. I'll show you some core photos of Jim's from that. This little red box is this, and here's Jim's close-up map. There's the Alleghany Formation and the Pottsville Formation. The Fallingwater House is located here. This is the Youghiogheny River, and this is Bear Run that cuts a gorge that drops down into the deep part of Youghiogheny Gorge here. So there's the position of the house. The quarry is where the building stone came from. It's less than 200 meters from the house. And there you can see Jim's cross section, and notice the Ligonier syncline in his, I'd say, very accurate cross section, accurately made. You see how flat bottomed the syncline is, and we're right near the axis of that, just a little bit on the flank. So let's zoom in and look at stone at Fallingwater. Here's Jim's map closer up. There you can see the formation boundary, which we put at the top of the sandstone here. There's the Brookville coal that's in the lower part of the Alleghany. The formation boundary is at the base, actually, of an underclay under the Brookville, not really the coal itself as we understand it. And then the other line here indicates the boundary between the Homewood sandstone, fluvial, coarse to medium grain sandstone typically, and the Fallingwater sandstone. I think we might call this an informal member. It does extend for a few miles in each direction, and it's a significant unit. It's distinct in being fine to very fine grained versus the Homewood typically being medium to coarse grained. Again, fluvial, lots of channels. You can see that there are some channel margin drapes within it. There's some drapes within temporarily abandoned channels too. You can see the different shapes of those. Before we leave this map, I'll also point out, I've put on springs. Some of them are intermittent springs. And those springs come up from the Brookville coal. It's highly fractured, it's good conduit for water, and it's got an underclay base seal. So it's a perched aquifer that sources some springs. And one of the key springs is behind the house at Fallingwater. I think it's coming from the Brookville interval, and it sources water features. So the water features here have a natural spring source, including the pool that's just down the hill from that spring. Another important feature of the landscape is the rhododendron, which love acidic soils just like hemlocks, another part of the landscape. And as Jim has taught me, there's some geology in the location of where those rhododendron are. So they're a beloved part of the landscape. And as Jim taught me, they tend to grow on acidic soils, on really quartz-rich sand bedrock. And the soils in the Alleghany Formation aren't as quartz-rich. There's more of a mix of a lithology there, not just a wad of quartz-rich sand like the Homewood here. So the soils aren't so acidic, and rhododendron tend not to thrive there. So if you take a look from the bird's eye view toward the house, you can see that the house and guest quarters are near the top of the Pottsville Formation, near the top of the Fallingwater sandstone. And beyond that, in the Alleghany Formation based soils, there just are no rhododendron at all. So it's a pretty neat relationship in terms of the ecology and the geology of the landscape here at Fallingwater. This is a look out at Paradise Overlook. There you can see the Alleghany River. There's a hiking trail that comes out here from the house. It's a nice place to go. And you can see these cliffs of Homewood sandstone support these acid soil loving rhododendron. There's one lonely little mountain laurel here, but otherwise there's no acidophiles in terms of plants over the Alleghany Formation up there. Here's the paleogeographic setting. I think you guys will know this quite well. You'll know that there were glacial and interglacial fluctuations here in the Pennsylvanian. Sea level went up and down. Here's a time of higher sea level than what's shown on this other paleogeographic map. I'll just mention that Fallingwater here, it's not surprising if there are paleocurrents coming from the south. A lot of people, when they think of the Pottsville, they're used to thinking of central Pennsylvania, where the classic studies put the provenance for that area being around Philadelphia, but we're not in that area. And there are provenance studies of the sediment in the Pottsville in western Pennsylvania that suggest petrographically and compositionally, it may have affinities to North Carolina provenance. So there could be a sediment provenance that's farther away than central Pennsylvania Pottsville. I wanted to bring this slide back. You can see I've highlighted key quarry. So this is an abandoned sandstone quarry. The CSX tracks are here. So I'm sure they would have used quarry rock either for the railroad or transported it by the railroad. But I called this key quarry because when someone comes along to really study the detailed sedimentology and stratigraphy within the Homewood sandstone, start there. It's a great quarry. The head walls has most of the Homewood in it. It's a fairly smooth surface. You can see channel forms. You can see, because they trend right into the outcrop, you can see channel drapes. You can see bar forms. The sedimentology that you can see there is just great. And I really didn't scratch the surface of that at all. It's sitting there waiting for someone to study it. Here's one of Jim's pictures nearby. This is a little farther west off that map. There you can see the base of the Homewood. It's a major erosional surface. I would say an important sequence boundary. Here's the fluvial Homewood sandstone, coarse to medium grained. The bedding here, the structural bedding is flat. This is the Mercer interval underneath, coastal plain, siltstones, a little marine brackish influence, and some coals, as you'll see later. So these inclined beds are filling a channel. There's erosion at the base here. It's cutting down. There's channel fills stacked here, channels going back and forth. You'll see some channel orientations later on. And the Fallingwater sandstone, the informal member, is right at the top of the cliff here. And I'll show you a picture of that next. This outcrop I called Bottle of Wine Overlook because it overlooks the Youghiogheny River, and you can see in here Bottle of Wine Rapids on the Youghiogheny. So here we are at the top of the cliff, and there's a nice planar flooding surface, some fine to very fine grained sandstones of that Fallingwater sandstone. Overall, beds becoming less amalgamated. Some of them you can get maybe a sense of coarsening upward, sort of parasequence, but the thinnest beds are at the top. And you can't see, but there are silts and shales in between the beds that you'll see later in the core. Not far away is the Fallingwater sandstone in the wild. So you see these really pretty planar beds, but there are a lot of ripple marks in this. And you can see they range from very, very thin beds to medium scale beds. In the lower part, there are some beds as much as a foot thick. So there you see the Fallingwater sandstone in the wild. I'm going to show you this cross section now. The house is at the star. FH on the cross section is going to be Fallingwater House. You saw Key Quarry was here. This is Bottle of Wine Overlook. There's the axis of the syncline. And see these lines? Those are channel axes I measured, orientations of channels based on measuring channel margins. There's another one here. And you can see that they're subparallel to the syncline, giving an idea that the earliest erosion, probably earliest deposition, was probably controlled by where the syncline is. And that goes along, that fits with Jim's evidence too, that I'll show you later on. Okay, there's a cross section I promised. There's the Mercer interval below. The lower Mercer in this area, it doesn't get cut out quite by the erosion on this major, I would say, sequence boundary, major erosional surface. The upper Mercer coal does get cut out in places though. And there's some really neat relationships along this. This is a place I called Peat Raft because there's a raft of coal surrounded by fluvial sandstone, probably was a peat mat that got eroded, fell into the river and washed away and surrounded by sand. And that's a really neat feature that Jim identified along here, Peat Raft. This is really cool too. This is siderite conglomerate in the very base of this erosional surface. There are cobbles of rounded siderite. There's siderite in the Mercer, and I'm sure that's what sourced that siderite conglomerate at the base of that erosional surface. Another feature is here. You see I put the major erosional surface with siltstone on top. This took me more than one glance to figure out. The bedding in the Mercer, this coastal plain unit, is very flat, very planar, flat bedding in the syncline here. And eventually I realized that there was a large block of Mercer with the bedding clearly tilted in toward the channel. And I realized that's a block of Mercer that got eroded. It must have been cohesive enough to hold together and came into that erosional surface. So that's a slide block that I think is a pretty neat feature. You can see that there are coarse lags. There are pebbles and granules sometimes in these channels. I'm sure that this is fluvial. It wouldn't shock me if some of the channels, maybe in the upper part especially, are distributary channels of a delta, but they're channels nonetheless. There are some flat drapes, channel abandonment drapes in the coastal plain. And as I mentioned, there are drapes that are inclined too. I want to talk to you about some of the things that I'm really not sure about and somebody ought to think about when they next study this. And one of those is this correlation right here. So this is a road cut along Highway 381. Unlike these others with flat dip in the syncline, this one's dipping about 12 degrees. So that makes it more difficult to use the terrain to be confident exactly how to correlate this. Clearly has good Homewood sandstone, coarse grained sandstone, fluvial below it, but it looks like it has some burrows in it. Now, Jim hates this correlation, and Jim maybe rightly thinks that this is actually correlated to this marine unit. The Fallingwater sandstone has lots of good marine trace fossils and clearly is marine. So it is possible that this correlates, and I've messed up the datuming here, and there's a facies change, and this is a little bit coarser facies of the Fallingwater sandstone interval. So I just wanted to highlight that as a possibility. When someone comes back to look at this again, that would be something to consider. But there definitely are places where there are cliff-forming quartzose units that from a distance anybody would call Homewood, and they're no coarser grained than medium to fine grain. So there are lateral changes here, and the sedimentology of this unit is just really great, and I hope somebody studies it. So you can see the nature of bedding. You see I'm showing some channels here also. It's not the same facies everywhere. Notice that the quarry is a place where the rock is gone and the upper part of the quarry really isn't exposed. But we'll look at some outcrops where it is exposed. So we'll look at a few here. Here are these 4 outcrops from that cross section. You can see the datum is the flooding surface at the base of the Fallingwater sandstone interval. And these are trace fossils that Grant taught me to identify. And you can see them listed down here. Some of them I think will be very familiar to all of you. This is the quarry where the upper 6 feet or so of this interval has been quarried. That's what's making up the building. That's what Fallingwater is built of. You might have noticed herringbone crossbedding down here. So wouldn't that be interesting to study the lateral facies changes of this unit, and gives you an idea that maybe there's some tidal influence here. This is a core, the OSP1 core that I mentioned, and it's a generalized version of Jim's description of the core. And you all know what sand and shale and siltstone look like in these. So it won't be a surprise that this is the upper part of the Homewood here. This is the Fallingwater sandstone interval in core in Ohio Powell State Park. The Brookville coal is just above this core box that ends at 641 feet. So it's just above this. This is the underclay. So the formation boundary is the top of the Fallingwater sandstone here. But look at the bedding. See the fine scale bedding, and then there's some thicker beds near the base, like we talked about in the Fallingwater area. Here you can see the fine grain units, though, these drapes. So the sandstones we think are storm deposits on a beach or tidal flat with some quiet water, silts and clays that were deposited in between. And when Wright gave instructions for quarrying, he said, take the stone as it comes from the quarry. So they used blasting caps to loosen it up. They didn't do major blasting. They carefully took pieces out, and they preserved the tops and bases of every bed that's used in the walls of Fallingwater. They have the original bed, base, and top preserved per Wright's instructions. And the reason they were able to do that is because there are these fine grained drapes in between the storm deposited sandstones. And Grant is an expert in tidal deposits. And when you look really carefully at the core, you can see some bundling. So Grant has suggested that he can see some tidal bundles in these sandstones. Again, we think most likely a beach or a tidal flat, maybe a tidally influenced beach. So here now you can see that there are both blocks and slabs that all came from that 6 foot thick interval. Where they're fresh, they're all light gray. They're all the same color. And those are original beds, tops and bases. They only could use ones that were pretty flat. If they were curved pieces, they ended up in the waste rock pile that's still sitting there in the quarry. So pretty flat pieces. And the first house that Wright built, where he used stickouts, he called them, and had some slabs of stone stick out an inch or two, was Taliesin in Wisconsin, the home and studio he built for himself starting in 1911. That was really his test bed for organic architecture, coming out of prairie style, which had more highly finished materials. The stone used in the prairie style houses I've seen pictures of, sometimes they had stone fireplaces, but it was sawn stone. They weren't chopped, rough, organic looking edges like this. And Wright talked a lot about staring at rock outcrops, wanting to kind of mimic those with the houses. And I think you can get that sense here with the slabs and these stickouts. Well, the stickouts, I think, also have an aesthetic function. Because where it's fresh, you can tell that the sandstone is all the same color. Without the stickouts, you really wouldn't be able to see that really nice stonework from any distance. The shadows underneath the stickouts really help accentuate the stonework in Fallingwater. And like I said, he first used stickouts in his own building at Taliesin, which was built starting in 1911, and Fallingwater came along in 1935. I'm working on a house now, stone Wright house on the Erie Lakeshore south of Buffalo, that was built before Fallingwater, and it's really his transition into building stone houses for clients in the organic style. Graycliff. If there's time or a question at the end, I do have some slides here. I'm working on a GSA guide. I'm going to lead a trip out of the Erie section up there, and hopefully we'll publish the first ever geology guide to Graycliff for that March field trip. Okay, let's look at some pictures of the quarry itself. So here's some historic pictures of the quarry, thanks to the Fallingwater archives. And Wright instructed them early on in quarrying. It was a pre-existing quarry, by the way. He instructed them to save slabs that were 1 to 4 inches thick and had fairly smooth surfaces to use in the late stage of construction as pavers. So you can see these slabs leaning up against trees next to the quarry. I think very likely those were the set-aside slabs to be used as pavers. And then within the quarry, you can see they're chopping blocks of sandstone to cart over to the house less than 200 yards away. These, I think, are about the same view. Recently, the Conservancy exposed the base of the quarry. There are some trace fossils in the sandstone here. The edges of the quarry really aren't exposed right now, but I think this is about the same view in this historic picture. And here's a historic photo of the house itself, the bridge, and these slabs leaning against the side of the bridge, I think staged and ready to be used as pavers. Here's another picture next to the pool during construction of the guest quarters area with these slabs again staged, ready to be used as pavers. Notice how the stickouts really help you see the stonework from a distance. It's all the same color and tone. Otherwise, you really wouldn't see them without those shadows. This is Walter Hall and his son, R.V. Hall. They're from Port Alleghanian in northern Pennsylvania. Walter built his own stone building, and he built a lot of others for other people in Port Alleghany in that area. But his own building in Port Alleghany, he built part before Fallingwater. And when Wright and Kaufman heard about the excellent stonework, the good other construction work Hall was doing there, they brought him on. Wasn't the first builder here. First one went away, but he was the builder for most of Fallingwater. So he has an important role here. And the building he built in Port Alleghany is called Lynn Hall. It's an Airbnb, and it's like staying in a Wright house. It's really great. The folks who own Lynn Hall now have done wonders with restoring it. I have some pictures of Lynn Hall. I hope we get to them. So here's a little more Fallingwater, building stone in the wild. You can see these thin beds, lots of ripple bedding. Notice how there's a little bit of erosion here and fill. So couldn't use this for building stone. It's too curved. You have to use the flat pieces. This sort of piece would end up on the waste rock pile. Here's some pavers, or here's a paver with wave ripples. There also are current ripples. There are climbing ripples. There are combined flow ripples and hummocky cross stratification. So you see hundreds of slabs. These are wall stone you're seeing from the side view. And you know that you can see the top and base of beds too, and hundreds of those slabs because of the stickouts. And then there are lots and lots of pavers to see ripple marks too. So here's some really nice wave ripples from low tide at Tybee Island, a tidally influenced area in Georgia. I picked out this one because at low tide, you can see how they easily get flat tops. This is the ebb tidal delta at the other end of Tybee Island, next to the inlet on the south. You can see these current ripples facing, showing that the current was flowing offshore. This is an ebb tidal delta, very different style of ripple marks. I don't think you need more explanation to see how different they are than the wave ripples. And there are both types at Fallingwater, both on the pavers and in the wallstone. Nice ripple marks that are clearly wave ripples, and some that are combined flow ripples and current ripples, all types. It's just great. It's a sedimentological treasure. There's the famous living room. Well, see another view of the living room fireplace later, but the living room is right next to and over the balcony here. This is over Bear Run. When you open the hatch, when you open the windows, when you open the doors to the balcony, you can hear the waterfall. The upper waterfall is just under here. You can hear Bear Run. You can smell it. It's really, you're close to the river here, or to the stream, to Bear Run. And they were careful to coat the stone here so that it looks wet. It adds that wet color or wet nature of the stone, or appearance of the pavers here, really aids the sense that you're right in Bear Run, that you're right with the water, you're one with the environment. And I think for a geologist, seeing these ripple marks in the pavers adds to that sense of being in an environment with water. So here's some vertical burrows in the intertidal zone at Tybee at low tide. To live there, you kind of have to live in a vertical burrow. Ghost shrimp burrows. In the ebb tidal delta, there's some polychaete burrows. There are both vertical and U-shaped burrows probably there. Look at this paver near the front entrance of Fallingwater. See the flat top linear burrows, and see the flat top linear ripple marks, and see the vertical burrows. So this is a good guess that this is from the intertidal zone of a tidal flat or a beach. It's hard to see that these are paired. We do think some of those are paired and arenicolites. This is an easier one to see that they're paired. This is from Edgar Sr.'s terrace. See how that one's bigger than that one? So this would be a U-shaped burrow of a filter feeder. This is the in burrow for the water and food. That's the exit burrow for the pellets. And you can even pick out which is which on this paver from a Frank Lloyd Wright house. Here's a really nice illustration from Pemberton and others, going offshore from a beach into the offshore with different types of trace fossils that you would expect. Of course, the vertical burrows, U-shaped and linear in that intertidal zone, and in the Scalithos ichnofacies. The bolder font here indicates types of burrows that Grant identified and taught me to identify at Fallingwater. And I think most of you are going to know the thalassinoides that has a vertical component and then a lateral branching component. Same thing with Ophiomorpha that's lined with fecal pellets to keep it open. That it has both a vertical component and a lateral branching component. I wanted to point out Gyrocourt too, because you'll see it's a double track burrow, and now you can see what kind of environment it represents. So here's an art object in Edgar Jr.'s study on the 3rd floor in Fallingwater in the main house. It's a few inch thick slab of sandstone that's set on end. The bedding plane here has iron oxide mineralization. I've seen that mineralization in outcrops too, on fractures and bedding planes. So you could go to Ohio Power State Park, get a permit, sample this same mineralization, do a little XRD, and give a very well-informed opinion to Fallingwater exactly what mineral this is. Hopefully by now you've seen the branching burrows here that Grant saw at first glance, and then you'll see these vertical ones too. So these are branching burrows, arthropod burrows like thalassinoides or Ophiomorpha. So the art object here has just great geology. It's got great trace fossils, creating the texture of it. Here's some trace fossils. This one's on a paver. I really love these sinuous ones that have an abrupt start and end. It's possible that could be from a swishing tail of a fish. Here's one that's in a stick out in a wall. These others are wall stick outs. There's the double tracked one, Gyrocourt, that I mentioned before. Some are very diminutive vertical burrows. There are other types of burrows. There's a moderate diversity of them here too. So here's some other wall stick outs. There's a tiny U-shaped burrow that you can see. You see the wall stones aren't all right side up. The masons weren't really trained to know, I think, which was right side up or not, or maybe nobody probably even cared. So just so you know, they're not all right side up. Some are upside down, some are right side up. So this is I think the bottom of one. Or this is the bedding top, but it's upside down. So these are right side up. You can see the burrows in them. There are just a lot of these. And you could think of this as a storm sand, again, a beach or tidal flat. Storm brought sand out. it was colonized, but maybe not a great living place for the things that live there. So these very diminutive burrows are pretty common in the thin sands. Here's an outcrop called silty top because it's a relatively fine-grained interval equivalent to the quarry in the upper Pottsville. You can see tiny burrows here, some tiny branching burrows on a bedding plane, tiny thalassinoides. There's one that even has a lining. So certainly someone could come along and do a much more refined study of the depositional environments and trace fossils of the Fallingwater sandstone interval. There also are what most people would call syneresis cracks or subaqueous sedimentary cracks in the sand. Here you see them in an outcrop. They're actually on the top of the sandstone bed. And this is a piece of float. You can see the shape of them. Most people, I think, who do sedimentology are very familiar with these, but these can happen when sediment that's deposited in one salinity, there's a different salinity water that comes over top and the sediment shrinks, and so it develops these cracks. Here's a paver from Lillian's Terrace that has syneresis cracks too, I think, and there are a lot of pavers next to the pool that have those. So that's another feature of the Fallingwater sandstone. Another feature of it is stylolites. Here's an outcrop of upper Pottsville sandstone on Fallingwater grounds with stylolites. You all know what those are. And those weren't used to walk on. They were too rough, but they were used as coping stones. This is the guest quarters. This stone is 11 feet long. There's another one that's 11 feet long over here. And here's the top surface. It's stylolites. These are coping stones on a carport wall. It has stylolites too. So they were able to use those as well. And maybe not everybody knows this. They're really common, of course, in limestones, but they occur in really quartz-rich sandstones too. And I've seen those in lots of outcrops around Fallingwater. Okay, so after I'd been looking at the stone here for a couple days, this is the wall of the house next to the driveway, and the entrance is just, this is the start of pavers going in toward the entrance to the house. So this is the route between the driveway and the main entrance. It's a very prominent spot. And there's one sandstone block that's different than all others. I haven't seen another one like it. This is all fine to very fine-grained sandstone. We talked about the tops and bases, ripple marks, all that. Look at this. It's coarse sand. It's exactly like Homewood sandstone. I can't prove where this came from, but it's just like the Homewood sandstone right around the house or below the quarry. And there's only one. It's kind of hiding above eye level. It's over 7 feet high here. There's just one block of coarse-grained sandstone. I'm hoping someday maybe an intern or somebody with a hobby interest will look at the correspondence between Wright and the folks at Fallingwater, Kaufman, and the workers, and find some reference to this, because I'm sure that this was placed intentionally, kind of a hallmark stone or a beauty mark stone that a geologist would really appreciate. The other thing I'll mention is you can see the crude lamination if you look at this closely, and you can tell that the bedding in this is vertical. And that's pretty common for coarse sandstone blocks to be chopped and set that way with bedding vertical. Here's Jim's map, and this was in the field guides for Ohiopyle and I think Fallingwater. The red is the thickness map for the Homewood, and you can see it's thick around the Ligonier syncline, Jim noticed, and it's thin on the anticlines. So it looks like the anticlines were active and growing during Homewood sandstone time. And again, at Fallingwater, we're right about here in the area of thick Homewood sandstone near the axis of the Ligonier syncline. I did some paleocurrent work, and this was meant just really to learn a little bit about this area in particular, but also to try to encourage people to extend this. So paleocurrents that had been published before, there was a classic paper by Mekala. I think it was a Harvard PhD, studied cross-bedding in the early 60s, published a classic paper on the Pottsville, including Ohiopyle. On Ohiopyle, he measured planar tabular crossbeds in the Pottsville. And farther north in Pennsylvania, he measured troughs. And the trough crossbeds had more dispersion than the planar ones. That was kind of the point of the paper, classic paper from '67. So I measured paleocurrents. I measured them at Bachman Rock, They're very clear there. Other places, these are equal area plots, just the way they used to make them. This is a median orientation. This is a lepidodendron log, a long one. Jim, I think it's over 30 feet long. It's exactly aligned along the paleocurrent orientation. Look at these orientations. Those are a lot different, and I'm very confident those are correct. There are plenty of measurements to be made there. There's actually another outcrop. Those are from Fallingwater. There's another outcrop at Fallingwater I didn't know about until after I'd written the guide. And the paleocurrents there look to me, just in reconnaissance, like they're pointed south. So there's got to be a story here with these paleocurrents. And remember the axis and those channel margins indicating channel trends with the heavy black lines. Well, there are channel trends at Ohiopyle Falls too, in the Pottsville, the Homewood sandstone that holds up the waterfall. On the side away from the visitor center, I measured 3 really nice channel margins, and they're very consistently aligned with the syncline. So I split out the paleocurrents. The lighter color part of the rose diagram, that's the part Meckel measured. They're planar tabular crossbeds. They're above the waterfall, well above it, nicely exposed. But below those, there are other crossbeds that are a little more northerly orientation. With the really low water this year, I was back here a week or two ago, and I poked around at the waterfall, again at really low water right now. There were crossbeds I couldn't see before, and there was one set I could see the top sets, and they were exactly aligned with the channel orientation and with the syncline. So it looks to me like there's an evolution of direction here is probably part of the paleocurrent story, but there's got to be some complications, whether it's part of a deltaic distributary, maybe obviously these channels got filled in and then the rivers ran right across this area. But I think the paleocurrent story in this area and beyond has got to be really interesting, along with the sedimentology and stratigraphy of the Homewood. So let's take a look at the Fallingwater House, the part of the Homewood sandstone that's exposed that the house sits on. I think you'll see that I think there's a channel abandonment fine-grained unit. That's a channel abandonment kind of drape there, and then some channels too. So this is the upper waterfall, and everybody will notice right away, I think, that there's a channel form here. There's silty sands deposited in this channel before it got really quartz-rich, clean deposits that turned into this really hard sandstone. So that's why there's a recess. But down here, this is the top of a channel fill. It's pretty irregular. I don't think it's a marine flooding surface. I think it's just a top of a fluvial channel. And this is the shale that drapes it on top. It's a couple feet thick. That's what forms the plunge pool of the upper waterfall. And you don't see any of it here because these are actually boulders. The shale's gone below these. It's been eroded away in modern times. So these are actually blocks that drop down a little bit. But you can see the shale over here, and there it is. I didn't take any samples. There's been no petrography, no composition, geochemistry, nothing like that's been done. It's all waiting for people to do. No microfossils, all that kind of thing would be really great for somebody to do here. Let's look at some more outcrops in the upper part of the Homewood. These are outcrops that all the people who visit Fallingwater will see. The tour path goes from the visitor center down the path here. Often they'll get this same look that we'll see, and then they go to the house and they walk right past this outcrop. So understanding these even more than my reconnaissance, that would be great too. Again, 7 million visitors since the early 1960s. So there's a motif I noticed here. There's scour and fill in the lower part, and then there's a pretty nice sand wave that goes across the top. There's cross-bedding in here too. This is one of those paleocurrent localities I measured and showed you. So understanding the sedimentology and depositional environments in detail of these rocks would be great and would help inform the public too. So here's a place that I call the cave. You can see the scour and fill. It's about the same geometry, the same depth as the one under or behind the upper waterfall. And again, there's scour and fill, and then there's a sand wave nicely cross-bedded across the top. And this is an underhang, rock underhang, because there are silty sands deposited in that on that erosional surface first, before there was a much more quartz-rich sandy fill later on. Doesn't this look like a rock shelter? It's southwest facing, next to a stream. The flat meadow is nearby, woodland all around it. Surely people used this in the past. There are a lot of places like this in the Lower Highlands. Jim can tell you where a lot of them are in Fayette County. And I think it would be great for someone to do an inventory and really study these and understand whether people use them. Also, I can easily imagine this really kind of underhang. I call it the cave. You know, it's not the sort of cave we associate with limestones. It's more of an underhang. It goes back tens of feet. So I can easily imagine mammals using this other than man, like Pleistocene megafauna. And something I'll mention, you know, people have figured out in South America that Pleistocene megafauna dug burrows. And I haven't seen that talked about in North America, but they would have had thousands of years to do it. There were cave bears, there were giant ground sloths, certainly capable of over thousands of years digging places like this out. And the way they figured out that they were burrows in South America was a geologist came along and he just didn't see the geologic process that would create some of those big sort of caves, I guess. And that might be an interesting thing to think about for some of these too. Wrote a land acknowledgement here. There have been people in Western Pennsylvania. Meadowcroft shows us since before glaciers left Pennsylvania for at least 19,000 years. These various peoples have had lots of different names. And, you know, we want to be as respectful of the land and its inhabitants as we can, and to recognize that the descendants of the people who lived here, maybe people who used underhangs like this as rock shelters, are still living among us today. So this is the driveway next to the main house, and there's scour and fill, and then there's a crossbed set going across the top. So that same kind of motif. The main entrance to the house is over here next to the driveway. So there's another picture of the upper waterfall, historic picture from the archives. There's that channel cut with some silty sandy fill first that made an underhang here, and then really quartz-rich sand, pretty amalgamated sand. Hopefully all you geologists will see that these are fracture sets that are intersecting, joint sets that intersect, and that's going to be a theme when we talk about the waterfall here. So there's your smile-shaped channel form in this UNESCO World Heritage Site. When you go off in the bushes on the side here, it becomes a sandstone on sandstone contact. Same thing, I think, on the other side. So it's not a huge feature, and it's you know, got these nice sturdy bolsters on the sides. So now when you look at this view, hopefully you'll see that these are fluvial sandstones, maybe deltaic distributaries. You can see a nice channel form here. You know that this is interpreted as a channel abandonment surface that forms a plunge pool. There's actually channeling here too. This is a more bedded sandstone than this really amalgamated one. And that's going to be part of my story when I talk about natural fractures. But notice how these two waterfalls are at different orientations. This is oblique to the stream trend. It makes the waterfall, it makes it look like the water's coming straight out of the house. It's not really. The waterfall trend is oblique to the stream, and that'll be a theme of something that we talk about later. So here's a map view. There's a north arrow. There's Bear Run. This is the main floor. There's the upper waterfall, which is more or less east-west trend. And there's a boulder that's built into the house. The house was built on this boulder that shows up in front of the fireplace, the hearth, the core of the house. The house was built around this boulder. And you'll see another boulder that's underneath this level. You can't see it in this plan view associated with the foundation. So this organic style house was literally built on boulders, around boulders. And I've seen correspondence. Coffin hired some engineers to give him some opinions. And I'm just looking at the time here. They advised him not to build a house on boulders, and he did it anyway. So this has a lot of organic design features that maybe other clients wouldn't have permitted, that Coffin did permit, and it's one of the reasons this is such a special place. So I see that it's 7:22. I think I'm going to stop. You can always look at the Fallingwater webinar on YouTube. It has all the full slide set in it. they're the boulders built into the foundation. This is a boulder that came off the wall here. The bedding's dipping down toward Bear Run. This is outside the house. Here it is inside the house with bedding dipping down toward Bear Run. There's some lepidodendron fossil that Jim identified right next to the driveway here. So I think we're kind of out of downs and time here if we want to preserve time for any questions. I'll just say that the house really fits in the tectonic grain of the landscape. The Bear Run the orientation here fits fold parallel joints, fractures, and the house really fits into that Alleghanian tectonic grain. And it also has the plan view orientation that Wright preferred. So let me stop there and try to preserve a little time for questions.
All right. Well, thanks, Fred. That was really good. And I'm sure we do have some questions. So those of you online, please put them in the chat. Here, want to start?
I guess, what do they do about intense rainfall events? How does that foundation handle it?
Yeah, that's a very good question, an interesting question. From the correspondence I've seen, the engineers realized that these bolsters for the foundation of the house, they actually impinge on the creek a little bit. See how smooth? Well, maybe you can't see it for the leaves, but the bedrock here is very smooth. That used to be part of the waterfall, but they've kind of narrowed the channel here a little bit. So you know what that does during flooding. And the living room has never been flooded. There's been water that's gone up. There are steps that go down from the living room to the stream level, and there's been water that's come up to 4 steps on those at times. So that so far hasn't been a big problem, but it is a concern. There's actually an artwork, a metal sculpture here, a figure that has a chain to get held in place when a flood is coming, so it doesn't end up down Bear Run someplace. But there are floods here. See how there are no boulders sitting here? That's because they've all been washed off. So there's something I did want to mention though. Ideas for future studies. I'm working on an archive and database of Frank Lloyd Wright house stone, but these would be great for someone to work on. Comparison of Bear Run and Cumber Run watersheds. They both have a waterfall at the bottom, so it's easy to monitor runoff. They're about the same size, and those would be great to compare and establish a baseline here in the Bear Run watershed to understand rainfall events and floods, water flow, and to do that soon rather than later, considering what climate change might do with rainfall events. For someone to come along and study the Fallingwater building stones, so this UNESCO World Heritage Site with outcrops on public land nearby, get a permit to study and sample them, do some good composition, sedimentology, that would be a great thing to do. And then the landscape evolution of the gorge, Youghiogheny and Bear Run together, and do some bedrock exposure ages, understand the chronology of erosion here in geologic time. That would be great in terms of scientific value and educating the public as well.
All right, Fred, we got some questions online. You had mentioned the shelter as being a possible location where previous occupants of that area would have used that as shelter. Is there any evidence that Native Americans lived in this area? Are there any artifacts?
As far as I know, no one studied that for this property. And I certainly didn't dig. That would be really improper. So it's just sitting there waiting for someone to create an inventory, because there are many of these Homewood rock overhangs, and then do a proper study of which ones were used when. I'll tell you that there's another place where mammals live. I found it when I was measuring a Homewood section. There's no path nearby. There's rock fall at the entrance. I could crawl in if I were maybe Jim and really brave, but no way I was doing that. But mammals live in there now. There's a rock fall easily I can imagine people having used that in the past. And I don't think anyone but me knows where it is, and maybe Jim, because he's looked at all these outcrops. So that kind of work would be valuable, I think.
Another question, and this is kind of related to Kent's question, is what about the constant humidity of being so close to the stream and waterfall? That's got to affect furniture, wooden portions of the building, but any concern on the structural integrity of the building?
Well, I mean, they're always doing work on this building. It's an expensive building to maintain, and it's important, so they do maintain it. There was work on the guest quarters just this year. Some years ago, they took up all the pavers, numbered them so they could put them back just the same in the living room, put steel cables to keep this cantilevered structure from tilting more toward Bear Run. So there's always work being done, and a lot of conservation to do. I think in terms of rainfall, the main issue is water getting into the house. And unfortunately, when they built these stone walls, and they're stone walls, they're not stone over concrete, they're stone walls, they built them hollow. So when water would get in the middle of those, then it would come out somewhere else, sometimes in the house. And you can see places, they're kind of like cave deposits where some calcified material from the mortar has dissolved and gone in the water into a spot and created, like a little cave deposit. So those kinds of things definitely have happened through time and will continue. Another thing I might mention, if somebody did a detailed study of the sedimentology, the petrography of the Fallingwater sandstone, the sandstone here has been exposed for about 90 years since it was quarried and the house was built. Hopefully this house will be here for a very long time into the future. I'm sure the conservationists would love to learn and hear from petrographers who could study much longer weathered pieces of outcrop from the state park nearby and learn about weathering and what to expect for the future.
All right, got some more questions. So have you been able to present this work to Western Pennsylvania University Geology Department to get students and mentors interested?
I have not been invited. No, I'm happy to do it. It's really easy for me to do. I will mention that on Sunday, I'm going to meet a group of 10 architecture students from Virginia Tech at Fallingwater, and I'm going to teach them as much as I can about building stone and geology in 2 hours at Fallingwater and on the grounds. And I'm going to bring, one reason I want to make an archive of building stone from Wright houses, I'm going to bring stone from other Wright houses to show them and use as part of the teaching, because they're very different than this material. Each one is a very different material. And the way those stones were used was very different too. Boy, I wish I had preserved time to show you what I'm doing at Graycliff, because it's full of Middle Devonian marine fossils, brachiopods and corals, solitary and colonial corals. It's got bryozoans. It's just great. In a Frank Lloyd Wright house, prominently displayed on the walls.
So I seem to recall, Fred, that in your other the webinar, you discussed more about the location and like how the location was selected. Amy asked, is the location of the home in part consideration of the available quarry, the proximity of the quarry that you showed, or was it the quarry exists because of the location of the house? Which came first?
Yeah, no, that's a great question. As I understand it, there was a pre-existing quarry there that they expanded, and it's not far from the house. But I think everyone who studied this thinks that, Wright visited the site, but then he was back in Wisconsin at his studio, and he asked for a contour map showing boulders, major boulders, and trees. And the map was kind of centered where this picture was taken from. And everyone thinks that Kaufman expected a house to have this view. It's a great view of the waterfall, and they really loved the waterfall on their property. But instead, when Kaufman showed up in Wisconsin to see what plans were afoot, he was shown this, the house on the waterfall. So the idea Wright had was, you're going to live with the waterfall. You'll hear it all the time. You're going to be right there. And I think that some people would have an idea that when you have a really nice view, it becomes stale eventually. So, boy, was this an interesting decision. And Kaufman went with it. Look at the architecture here. Look at the spacing of these channel fill deposits and then abandonment. And look at the spacing of the house. And look how you step back away from the viewer. And look how that terraces step back away from the viewer. So that's part of the organic theme here. And the location of the house in that particular spot was a big surprise to Kaufman. But boy, is the world glad that it was done and that he went along with it.
You guys have any questions? Bill?
I toured the house about 30 years ago, and I know at the time they're touting it as the house of the future. Are they still doing that? It was.
Go ahead.
My take on the house as a human being was that it was very cold, hard, and damp. And I could easily see why the Kaufmans, after a period of time, found it quite uncomfortable living there and decided to give it away. And I made that comment on, and another woman on the tour really keyed in on that. She absolutely despaired of the idea. She was in despair because there was no walls in that house that she could wallpaper.
Yeah. Okay. This is an artwork, and I have to disagree with you in part of what you said. Everything I've seen in the correspondence I've read, the Kaufmans loved this house. Mr. and Mrs. Kaufman, Edgar Jr., they loved this house, and they spent a lot of time here. It's just a beautiful space and a great place to be. I think the modern part of it might be, it has a living room. We're kind of used to common areas and large living rooms today, but the living room, the way it's done, I think that was a nod toward something that was copied maybe by others later on. But the Kaufmans loved this house. Edgar Sr. and Lillian passed. They passed the house on to Edgar Jr. And before that happened, Edgar Sr. Coached Edgar Jr. in finding some way to preserve this for the future for the people. Edgar Jr. didn't have any kids to hand this down to. So he very carefully selected the Western Pennsylvania Conservancy to preserve this long into the future, which they have done. There were a lot of land holdings then of the Kaufmans, but the Conservancy basically bought up the rest of the watershed. So it's almost all woods to preserve the quality of the stream. And it's just a world's treasure. It has global significance. They didn't give it away because they didn't like it. They donated it to the world, found someone worthy of maintaining it. And as a marker for how worthy the Conservancy has been, part of being selected as a UNESCO World Heritage Site is the people who make the decisions on sites have to be convinced that this site will be preserved forever in perpetuity. And they were convinced about that for Fallingwater and the Conservancy.
Fred, this was just amazing. And an hour just wasn't long enough. So I think we're going to have to invite you back, especially, no, not a 2-hour session, but especially with the work that, this ongoing work that you're doing. So I'd like, if you guys agree with me, that I think we should bring Fred back sometime. So thank you so much.
Work me on part 2.
Well,
So-
if